Hi students, welcome to S&M Coaching Center. Today we will explain to you how to draw the convenient rays for a concave mirror. So since it is concave mirror, first draw the concave mirror. Now which will be the reflecting side? Since it is a cave, which means the inside part will be the reflecting one. So this outside will become the non-reflecting. So put dots like this. Now the center of this mirror will be called as a pole, and if you draw a line passing through pole, that would be called as principal axis. So draw a line passing through pole, it would be called as principal axis. And for a concave mirror, the center of curvature will be in front of the mirror. Call it as C, and the focus, it will lie in the midpoint of C and P. So do not write focus like this, such that there is a difference between C to F and F to P. No, you cannot write. You, by conscious effort, try to put F exactly at the center, if not exactly, at least approximately at the center of C and P. So CF should be equals to FP. Always focus is the midpoint of C and P. Now the moment they say draw any ray diagrams or convenient rays or whatever for a concave mirror, these are compulsory. Your CFP and then the mirror part along with the principal axis. Now, what is the first convenient ray? If a ray passes through focus, if a ray passes through focus, if the ray is passing through focus, no. What kind of ray is this? Incident ray, which means it is coming towards the mirror. So the arrow should be towards the mirror. Do not forget to draw the arrows, children, very important. So the moment the ray is passing through the focus, how will it reflect? It strikes the mirror and then it will reflect, right? How will it reflect? It will reflect such that it will be parallel to the principal axis. This line is called as the principal axis. So it will bounce back such that it will be parallel to the principal axis. Now since this is what kind of ray is this called? This is called reflected ray, and reflected ray is moving away from the mirror, and hence this should be, the arrow should be directed away from the mirror. So this is the first convenient ray, which says if an incident ray passes through the focus, the reflected ray will be parallel to the principal axis. Let us come to the second one. We have to draw again one more convenient ray for the concave mirror. The moment I say concave mirror, draw a concave mirror. Inside part will be the reflective side. The center should be called as a P. Draw a line passing through P, which will be called as principal axis. Then the center of curvature will be in front for a concave mirror. In between C and P at the midpoint will be your focus, will be the focus. Second one, if a ray of light passes through center of curvature. Now, how is the ray of light passing? It is passing through the center of curvature. So, since this is the incident ray, how should be the arrow? Towards the mirror. How will be the reflected ray? Bounce back in the same direction. So, it will retrace the path. So, it will go back in the same direction. So, for the same ray, you put the reflected ray arrow also. So, if a ray of light is passing through the center of curvature, it will bounce back in the same direction. This is the second convenient ray. The third one. Keep drawing the concave mirrors, children. Center is called as a P. P for pole. The line passing through center of curvature and the pole is called as the principal axis. This is the focus. Now, the third one. Incident ray is passing parallel to the principal axis. It bounces in such a manner that it passes through the focus. It passes through the focus. Arrows are important. Incident ray, it is moving towards the mirror. So put the arrow towards the mirror. Reflected ray is moving away from the mirror. So the arrow should be away from the mirror. If the incident ray is parallel to the principal axis, the reflected ray will pass through the focus. The fourth one. Incident ray strikes the pole. So this becomes your angle of incidence. The angle between the incident ray and the principal axis will be your angle of incidence. Then how will the reflected ray behave? Now it will bounce back in such a manner that whatever angle of incidence is happening, the same angle you will get as angle of reflection. So you get a reflected ray on the other side of the principal axis, such manner that angle of incidence is equals to angle of reflection. These are the four convenient rays.